Let's start then. Today we will focus on the review of Chem 20 that is in regards to how can we move from molar mass from mass to moles, not quite molar mass. It's mass to moles. So mass to moles. And how can we go from moles to mass? So those will be the two ways in which we are moving into the uh, review for today. So remember what we said in a previous video and a previous lesson about calculating the molar mass. So if we have a compound, then we will see how many atoms of each compound we have, and then from there we will calculate the molar mass of that compound. And the molar mass is a number that is telling us what is the mass if we have 1 mole of that compound. So let's suppose that we have a compound, carbon dioxide, then we have a number that represents that if we have this amount, that means that we have 1 mole of that compound. A mole, you know, from science 10 and chemistry 20, that is a new unit that is introduced to you in chemistry just to make sense of the mass, to perceive better what is that you are dealing with. Now, when we are talking mass, then it's in grams. So the unit, in terms of the unit, because even working with units will help you to understand what you are talking about. So molar mass has always units, grams per mole. So it is indicating how many grams are in 1 mole of compound, mole of any compound that you are dealing with. When we are talking mass, then the units for it are grams. So you are saying this is the amount that we have. Okay, and then when we have moles, the units are just mole. So keep this in mind, because even as I have said even prior, is that is important for you to know what is that you are dealing with. Okay, now when we are moving either from mole to mass or mass to mole, when we are doing the transformation, then what we are using is molar mass. So as the very first step as to moving either from mole to mass, mass to mole, we have to, step 1, calculate the molar mass of the compound. If you don't know, usually you don't, so you have to calculate. And then as the second step will be depend on what we are doing. So I will say, just to generalize it, not make you remember a lot of steps for a specific case, will be do stoic. Now, when we heard the word stoic, we are wonder as to, oh, I'm scared of this. Do not, because stoic is a simple math. And what we are doing when we are working with stoic is actually canceling the previous unit. What do I mean by this? I will bring you into go a bit away from chemistry so that you can see as how easy it is. Let's suppose that we have 5.82 kilometers. And what we want to do is we want to convert this into meters. So then what we do is we say 5.82 kilometers, this is what is given, and you always start with what is given, 5.82 kilometers. in order to move from kilometers to meters, what are we going to use? We'll use the ratio that connects the kilometers with meters. So what do we know from units that we have in our data booklet or so, is that 1 kilometer is equal to 1,000 meters. This is the same as saying that if I have 1 kilometer, then I have 1,000 meters. Or if I have 1,000 meters, then I have 1 kilometer. Now, in other words, what that means, if we are writing it as a ratio, since we are talking about the same thing over the same thing means 1. So if we are writing it as a ratio, 1 kilometer over 1,000 meters, or 1,000 meters is 1 kilometer, what we are doing actually, we are saying this is 1. And when you multiplied, so this is a ratio of 1, this is a ratio of 1. And when you are multiplying anything by 1, you are not changing anything into that. So now, you have two ratios, ratio 1 and ratio 2. And since we start with kilometers, what do we have to multiply it by so that we can cancel the kilometers? With a ratio 1 or with a ratio 2? We'll multiply it with a ratio 2. So ratio 2 is 1,000 meters over 1 kilometers. Because it doesn't really matter, still is 1. Even the first one is 1, but we will use the ratio that it's at our best interest to cancel the previous unit. So then kilometers and kilometers are canceled out. So in other words, if kilometers are in numerator, then kilometers has to be in denominator. Or if kilometers are in denominator, then has to be in numerator with the ratio that you are multiplying by. So what do you have now are the units in meters. So this will be a 5.82 times 10 to the power of 3 meters as the final answer, considering the significant digits. Okay, so this, whatever we did here, is stoic. Stoic in the word stoic is because it is for the specific, it's mathematics for chemistry. This is what it means, stoichiometry. And what do we do here when we are using stoic is we are using the molar mass. As we said, molar mass is the ratio of 1. So if we have 1 mole, then we have that many amount. When we have that amount, then we have 1 mole. Means that we have a ratio of 1 that we are dealing with. Let's suppose now that we are finding how much is how many moles there are in how many moles there are in in 4.82 grams of sodium sulfate. So, as I said, the very first step that we will do is we will calculate the molar mass of sodium sulfate. What do we do when we calculate the molar mass of any compound? We figure out how many atoms of each do we have on that compound. So we have 2 sodium, and then we have 1 sulfur, and we have 4 oxygen. And then what we do is we go to the periodic table, and then we say 2 sodium. So 2 times 22.99 plus we have 1 sulfur, 1 times 32.07, and then we have 4 oxygen, 4 times 16.00. Always write the 00, even though that it looks redundant when we enter it into the calculator, but so that you are indicating, if this is a written response, you are indicating that you are taking into consideration significant digits. Enter this in your calculator as you see, and then you will find the molar. So the molar mass is 142.05 grams per mole. Remember what I said, that the units for molar mass are grams per mole? What does that number mean? It means that if we have 1 mole of sodium sulfate, then we have 142.05 grams of sodium sulfate, or vice versa. So go both ways, which gives us the right to say that, okay, if I write it as a ratio, then I have a ratio of 1. So that means that when I write it as a ratio, I just put them one on top of the other. So 1 mole of sodium sulfate is 142.05 grams of sodium sulfate, or if I have 142.05 grams of sodium sulfate, then I have 1 mole of sodium sulfate. Okay, so what am I doing on this case? I am making 2 ratios, ratio 1 and ratio 2. Those are both ratio of 1. So it's the same thing. It's the ratio of 1. So ratio 1 and ratio 2. Then I start with what is given. So what is given on this case, we go back to the problem, is 4.82 grams. So always start with what is given, 4.82 grams of sodium sulfate times. What is the ratio that I have to multiply 4.82 grams by so that the grams are cancelled? A ratio 1 or ratio 2? Ratio 1, because grams are at the numerator, at the top, and on a ratio 1, grams are in the denominator or at the bottom. So 142.05 grams, it's 1 mole. So grams and grams are cancelled out. And even when you are working, especially if you are not used to this way of working with stoichiometry, cancel this out, because you will be able to see, even if you make a mistake. So you will be able to see, are the units cancelled or not? So then what do you have here as a unit is moles, and this is what we want. So then in terms of mathematics, what we have here is 4.82 times 1 mole of sodium sulfate over 142.05. And then entering in the calculator, we will find that number of moles. The calculator gives 0.03393171 moles of sodium sulfate. However, the calculators, I always say this, guys, and do not take it as offensive. The calculators are just stupid numbers. They are stupid boxes. They are giving us a number, but we have to take that number and then interpret and write the final answer. So then what we have here as the final answer, we have to take into the consideration the significant digits. We started with 4.82. And on this information, it's the only information that we have. In this information, the number of significant digits is it's 3. Therefore, the final answer should be with 3 significant digits. So now, what that means is that we must write it as a scientific notation form. So we'll take the decimal point and we'll move it to after the first non-zero digit into our answer, into the answer that the calculator gives us. So will be something like 3.393171 moles of sodium sulfate. And when we see this, still it's more significant digits than what we are looking for. We want 3, only 3 significant digits. So then that means that this is the first significant digit, this is the second significant digit, this is the third significant digit. With this is times 10 to the power of -2. So we'll stop here. As we stop here, we take a look at the following digit. So then the digit or the previous digit, the digit that we stop at, will be as it is. It will not be rounded up or rounded down, because there is not such a thing, as 3.39 times 10 to the power of -2 moles. Now, if you want to write it as a decimal, yes, you can. You can write it as 0.0339 moles of sodium sulfate. I prefer to write it in a scientific notation form, but there is no mistake writing it into significant or decimal form. Both of them are correct. This part was the part where we were moving from mass to mole. Now what we will do is we will move from mole to mass. So let's suppose that we have a question that is asking us what is the amount of carbon dioxide if 3.254 moles of carbon dioxide are accumulated, are collected. So amount is the question mark. Great. So as I said, the very first step, because we always mass to mole, mole to mass, we'll start with the molar mass. The first step will be to calculate the molar mass of carbon dioxide. And we calculate the molar mass of any by figuring out first what are the atoms that this compound is for. So we have 1 carbon and 2 oxygen. And when we have 1 carbon, means that we have 1 times 12.01. And when we have 2 oxygen, means that we have 2 times 16.00. So then after we enter this in the calculator, we'll find that the molar mass 44.01 grams per mole. Remember, molar mass is always grams per mole. Even if you are stuck on the diploma, looking at the units, this is a tip that you should use. Looking at the units will give you an idea what is that you are dealing with, and then you may start working backwards. What does that mean? What does this number means? Means that if we have 1 mole of carbon dioxide, then we have 44.01 grams of carbon dioxide. Or if we have 44.01 grams of carbon dioxide, then we have 1 mole of carbon dioxide. This is the first step. The second step is do stoic. So stoic means that you are starting with what is given, and in our case is given 3.254 moles of carbon dioxide, and then you move using the ratio of 1, which are those two ratios here, ratio 1 and ratio 2, so that you cancel the previous unit. So you want to cancel the moles of carbon dioxide. Which ratio do we have to use in order to cancel the moles of carbon dioxide? In other words, which ratio, 1 or 2, has the moles in the opposite place? If moles are at the top, then on the ratio, you will look for moles at the bottom, and it's a ratio 2. Good, thank you. So it is 1 mole of carbon dioxide. So moles and moles are canceled out. 44.01 grams of carbon dioxide. So then what do you have here is grams of carbon dioxide. And then as you enter it in your calculator, you will find how many grams of carbon dioxide, 8.245. It's 143.20854 grams of carbon dioxide. But this is what the calculator gives you. And calculators, being stupid boxes, gives you a number that is as big as this one here, or as long as this one here. However, we started with this, that is with 4 significant digits. So the final answer has to be with 4, respecting the significant digit rules. So it's 4 significant digits is 143.2 grams of carbon dioxide. And this will be your final answer, which you can leave it as a decimal as you have it here, or you can write it as a significant digit, 1.432 times 10 to the power of 2 grams of carbon dioxide. Both answers are correct. And this is when we are moving from mole to mass, from mass to mole.